this is the second video of geometric sequence and series. We have already found that there is a ratio between two terms in a given geometric sequence is going to be the same, and we also studied the rule of writing a general formula is a times r n power n minus 1, where a is the first term of this given sequence, r is the ratio between the two terms, and n is the last term of the sequence. If a sequence has the first term a is equal to 1 and the common ratio r is equal to 6, write the formula that describes the geometric sequence. So the value of a and r which we need for this equation is given. So we are just going to substitute the values. an equals a, that is 1, times r, that is 6 to the power of n minus 1. So this is the general equation for the given sequence. Write the formula describing the sequence 2, 10, 50 and 250 and so on. Here the value of a and r we have to find. A is the term, that is the first term, and r is the ratio, right? So we are going to divide the second term and the first term to find the ratio. Okay, so since we know the value now, we're just going to substitute in the equation. an is equal to a, that is 2, times r, that is 5, n minus 1. Okay, and never we should multiply this 2 and 5 and write 10 n minus 1, because this n minus 1 is only for 5 and not for the term 2. Okay, next sum is minus 9, 3, minus 1, half and minus 1 by 9. So this alternating negative factor indicates that the r value is going to be a negative number. This is a small idea we have to just keep in mind, which will be helpful in some problems. Now the value of a is minus 9, and we are going to find the value of r by dividing the terms. Okay, so it is going to be minus 1 by 3. Some people may ask why you are taking always the first two digits. We will also take the third and the second one. Then also the ratio will be the same because it is a geometric sequence. Okay, so once we know the value, we substitute in the equation, writing the general formula. Okay, now we will move on to the next problem. Write the formula of a sequence with two given terms. Okay, so we'll just start with the second example. 8, 4 is 375 and r is 5. So we have the value of r, right? And we want to know the value of a, so that we'll be able to write the expression, right? How to find the value of a1, that is the first term a. So we all know that a4 can be written as a times r power n minus 1, that is r cube, that is 4 minus 1, right? Here we just substitute the values that we know. a4 is 375, a value we don't know, and r value is 5, and n minus 1, that is 4 minus 1 is 3. So by substituting the values, we are going to find the value of a, which is going to be 3. Once we know the value of a and r, we are able to write the equation very easily. 5 times n minus 1. Okay, so we have to find the value of a so that we can derive the equation. Now here we have got the value of third term and eighth term, and we haven't got any value for A, and we haven't got any value for R. So that means we have to first find the value of R. So we know that there are three numbers, right? A3, A4, A5, A6, A7 and A8. That means there is a R between these two numbers, another R here, another R here, another R between this and the R between this. So there is going to be 1R, 2R, 3R, 4R, and there's going to be 5 R's which we have to multiply so that we can find the value of A8. This is the same as we did finding the difference between the arithmetic terms. Here we are finding the ratio between the arithmetic terms. So there are 5 terms in between. So there are 5 ratios in between these 6 terms. We write A3 term times R to the power of 5 will give you the value of A8. So here we know the value of A3, which is 12, R to the power of 5, and A8 also we know the value. So R5 is equal to 384 by 12, okay, which is going to be 32. So R power 5 is 32, means R is going to be 2. Okay? 2 times 2 times 2 times 2 times 2 is going to be 32. So we have found the value of R. Once we find the value of R, we can just substitute that in this equation. Right? We know the value of A3. We know the value of R to the power of n minus 1. So 12 by 4, which is equal to A, which is going to be 3. So A is 3 and R is 2. So easily we can write the general equation, which is 3 times 2 to the power of n minus 1. Okay. So whatever the terms they give, with which we are able to derive the general formula. That's what I want to show with these examples. Next, we will move. Here, given the first term and the common ratio of a geometric sequence, find the recursive formula and the 3 terms in the sequence. So recursive formula is that an equals an minus 1, that is the previous term of an, times r. Okay, whenever we know the previous term's value, then it's easy to find the value or the next 3 terms or 5 terms of the sequence. So for example, they have given the value of a1 here, right? So we want to find the value of the next 3 terms. So a2 equals a2 minus 1, that is n minus 1 times r, right? So that is going to be a1 times r, which is 2 times 6, which is going to be 12, right? So a3 equals a2 times r, right, which is equal to 12 times 6, 72. a4 equals a3 times r, which is equal to 72 times 6, which is going to be 442. Okay, so this is going to be the next 3 terms after the given number in the geometric sequence. Okay, so this is a very easy method. Whenever the previous term is given and we are asked to find the next 3 terms after the previous given term, it's very easy to use the recursive formula. Here the value of a4 is given and r is given, so we will be able to find the value of a5 by means of multiplying the value of the previous term with r. That is going to be 25 times minus 5. It is going to be minus 125. So a6 is equal to the previous term times r, right, which is going to be 625. Okay, so a7 is equal to a6, that's the previous term, times r, 625 minus 5, which is going to be minus 3125. So the terms after the given number is, see, we are getting one positive number excuse me, and the next term is a negative term because the r value is a negative value, right? Just keep this in mind because in next text problems it will be helpful for us. Okay, now write the geometric sequence using the given general term. They were given the general term. Now we are supposed to identify the geometric sequence. So it's very simple, right? Here the value of a is identified as minus 3, right? And the value of r is equal to 8, right? Because that's a general sequence we are going to compare, right? A times r n minus 1. So when we compare that, a is minus 3 and r value is 8. Once we find that, it is very easy using the recursive formula. A2 equals minus 3 times 8, which is equal to 24, right? And a3 value is 24 times 8, right? Okay. Okay, 192. Okay, so this is going to be the geometric sequence, minus 3, comma, minus 24, minus 192. Okay, so in this next problem, the a is identified as minus 1 and r's value is identified as minus 2, right? So a2 is going to be minus 1 times minus 12, that is 12, and a3 is equal to 12 times minus 12, that is minus 144, right? So the series is going to be minus 1, 12, minus 144. We are able to see the alternation of negative and positive in the terms because of the presence of r's value as negative. Okay, so with this we are closing today's video. I hope you have understood the explanations. We keep watching the series so that you'll be able to understand the whole geometric sequence and series and the related word problems. Kindly subscribe the channel and comment.